Hi everyone, myself Jaran Shevak, URK23I1070. Now we are going to build a neural network that predicts the house pricing using the built-in dataset from the skitlearn powered by the TensorFlow and Keras. So now we are going to import the libraries, that is NumPy and Pandas for the data handling, Matplotlib for the data visualization, then the skitlearn for the data pre-processing, and TensorFlow Keras for the neural network model. So what are the we like import numpy SNP, then import pandas SPD, then import matplot with pyplot as PLT, then all the scalar and TensorFlow libraries we are going to import it. Then what we are going to do is we are going to load the dataset. So we load the housing dataset, which includes the features like population, number of rooms, and average income, and the target variable is the median house value. So that we have given data is equal to fetch California housing of then pd dot data frame of data dot data comma columns is equal to data dot feature names, then y is equal to pd dot series. So we are going to do that. Then we are going to print the dimensions. So we are going to do print shape of x comma print shape of y, so that by that we can able to print the dimension. Then what we are going to do is the main part is the feature scaling. So since all the features have the different ranges, we use a standard scaler to normalize them, so that ensures our model print efficiently and coverages all the elements. So what we are going to do in that means scalar is equal to standard scalar of then x scaled is equal to scalar dot fit transform of x. So then we are going to split the data set because there we have a large amount of data sets, right? So we are going to split that. So so we split the data set into training and testing. 80% of the training and 20% for the testing. Like X train, X test, Y train, Y test. In that way, we are going to split that and we are going to do. Then we are going to build the neural network. So this is like we defined a simple sequential model over here. So the first layer has the 64 neurons with a relu activation function, and then the second has the 32 neurons. So and the output layer has the only one neuron, since we are predicting a continuous value. So as we can see in the code that the model dot add the dense of 64, and we are activating the relu function, and we are also activating the redo function by using the denses 32, as we can see here. Then we are going to compile the model. So we are going to compile the model with the Adam optimizer. So we are using the mean square error as a loss function and the track mean absolute error as a metric for the easier interruption, as we can see here. Then we are going to print that value. Okay, then we are going to train the model in here. So we train the model for the 8 epochs with a batch size of 32 and with the 20% of the data for the validation, as we can see here. History is equal to model dot fit of x train comma y train, then the validation, as we can oversee. After that, what we are going to do is we are going to evaluate that model. So after training, we evaluate our model on the test set to check the performance. So that loss comma m is equal to model dot evaluate, as we can see over that here. So after that, what we are going to do, we are going to visualize the performance. So we are going to visualize the training and the validation loss, as well as we can as well as a mean absolute error over a post. This helps us see how well the model learned during the training. So we are going to do with the plotting point. After that, what we are going to do is we are going to find the prediction. So finally make a few prediction to compare with the actual values. So y pred is equal to model dot predict, then for I in the range of, then we are going to print that, and we are going to do everything. Then we are then after that last we are going to print everything. So in this we built a neural network that predicts the California house prices using the deep learning, and and we have done the experiment well. Thank you so much.